4.3 is on phase shifts. So today we're going to construct a graph with phase shifts, which means that we're moving our graph left or right. So far, when we're working with sine and cosine, there are a few different parts of the graph that we have talked about. The first one was the amplitude being the absolute value of a, which is the value in front of the equation. Then we also talked about how the period for sine and cosine, also secant and cosecant, is 2 pi over b, and that b value is always right in front of the x value. And then lastly, our phase shift is negative c over b. So we just take that c value and put it over b to figure out what our phase shift is. And if our phase shift is negative, we're going to move it to the left, and if it's positive, we're going to move it to the right. And we've also talked about how if a is less than 0, then the graph will be reflected over the x-axis. So if we look at this red graph down below, the amplitude for this is going to be equal to 1. The period is equal to 2 pi, because that's the length of a full cycle. And then the phase shift, because we have the equation of sine of x minus pi over 2, our phase shift is negative pi over 2. So this would be negative pi over 2 because there is a negative sign there, divided by our b value, which is 1. So this would end up being just positive pi over 2, which is why our graph was moved pi over the 2 units to the right, which is our phase shift. So now we're going to do some examples where we are going to construct the phase shift. So for graph 1, we are going to graph one complete cycle of y equals 2 sine of 3x plus pi. So we're going to identify all of the parts of the graph to start with. First, we're going to identify our amplitude, which is 2. Then we're going to identify our period, which is 2 pi divided by our coefficient of x, which would be 3. And now we're also going to be talking about our phase shift, which is negative c, which would be negative pi over our b value of 3. And if we had a vertical shift, that's when we're adding or subtracting something on the outside, and this time we don't have any. So these 4 things you're going to want to be able to calculate just by looking at the equation of a graph. Now we can start by drawing our axes, now that we have all of that information. So we're going to graph one complete cycle, and one complete cycle is going to be between 0 and 2 pi over 3. So if we were to cut that in half, we would get pi over 3, pi over 6, and pi over 2. Then we have negative pi over 6. Just need to extend this side a little bit further. And negative pi over 3. And because this is a sine graph, we already know our amplitude is going to be 2 because we already calculated that. So to start off with, we are going to graph this, completing our new amplitude and our new period. So we're going to start by drawing our sine graph with an amplitude of 2 and a period of 2 pi over 3. So we know it's going to make one complete cycle between these 2 points. And we always start by going from 0 to our maximum, down to 0, and then to our minimum. So right now we have this parent graph, which is just y equals 2 sine of 3 pi. Now we're going to complete the phase shift where we're going to be adding pi, which means our phase shift is shifting our graph a total of pi over 3 to the left. So we're going to move this starting point to negative pi over 3. For this point, we're going to move it 1, 2 to negative pi over 3. Move it over 2 spots. We have a new point there. Move this one over 2 spots. And move this one over. So this is where our graph would end up moving when we shift it pi over 3 units to the left. So the purple one is our final graph. All right, moving on to our second example. This time we're going to graph cosine from negative 2 pi over 3 to positive 2 pi over 3. So again, we're going to start by identifying these key components. Our amplitude is our A value, so our amplitude for this one is 2. Our period is 2 pi over 3. Our phase shift is negative c, so negative pi over our b value of 3. And then our vertical shift is anything added or subtracted on the end. And this one, we do not have a vertical shift. Now we can start by drawing our axes. And we're going from negative 2 pi over 3 to positive 2 pi over 3. And again, when we start by graphing this, we're going to graph our parent function with the new amplitude and the new period. So we're going to start by graphing y equals 2 cosine of 3x. And cosine always starts up at the maximum, goes down to 0, to our minimum, maximum, or 0 again, and then maximum. So this is our parent function that we are going to use, and then we are going to complete the phase shift. There we go. All right, so then we are moving this graph negative pi over 3, which means we're moving it left. So some of these points aren't going to stay on our graph. If we were to move this point, that one would disappear from our graph, so we wouldn't have that anymore. Same thing for this point. It wouldn't be in the domain that they've asked for, so we don't need that one either. So our first point we're going to move is this one, and we're going left negative pi over 3, which is 2 of our dash points. So we're going to move all of our points over 2 marks, which would be negative pi over 3. One, two, 1, 2. So this is all of the points that we had from our parent function. And you'll notice that does not cover our entire domain. So we're just going to continue the pattern and add the extra points that we need to get it through the domain that they have asked for. So then that is what the complete graph would look like with a phase shift. So notice we just took the same graph and we moved it over to the left. All right, so that is what your homework assignment is going to be on today. If you have any questions, just let me know and I'll get back to you as soon as possible.